null, right? It's not in there. This told us the whole story anyway. True? That's great. All right, hey. I just love to interpret the p-value. The key is we just got to state our conclusion, right? And when this p-value is 0.14, this is the probability I just love interpreting this. This is the probability of obtaining these statistical results or more extreme if
mu d
sub d, difference in the means, has no difference, which is equal to what?
0.
So this is probably obtaining these statistical results or more extreme. And I'm going to write it. You go, what statistical results? The probability that t was greater than or equal to that 1.14.
So
So if you're wondering, what are you talking about? Statistical results. The odds that I could shade from here over. That would be that probability. This is the probability of obtaining these statistical results are more extreme if mu d equals 0. But because, you know how to do this, right? Because my p-value
it's greater
is greater than the
alpha.
alpha level, what do we do about the null?
We do not reject.
We do not reject null. We do not reject H naught. We do not reject the O. H naught O. Because this is higher than that. Things in this world, that wouldn't be unusual to get this. So we can't go against this.
No.
And you know, when I told you I use 92 octane. But there's other things you hear about getting it makes the car last longer and stuff, better for the engine, etc. You're going to drive your car forever. Anybody else going to keep their car as long as they can? Like me, yeah, me too. Just keep driving the thing till it dies.
So are these data like, did they really perform a test or did they just made it up?
Great question. I was wondering that too. I thought it's an interesting problem.
Uh-huh.
It sounds like a real story, but I don't see any source here in the textbook problem. I could always email the author, find out if I ever run into him, ask him is it real deal. It's a lot of stuff though. What course did he use that modeled the what? The city and the highway? Who was it? Someone put a little effort into this thing. Awesome. So when everything is done, except for this. We did both the p-value approach and the classical approach. What's my conclusion? This is where you say, there is evidence. Here comes my conclusion. Let me write conclusion. What do you mean by conclusion? I finally get to this. Is there evidence for this?
No.
No. Sorry. There is not sufficient evidence.
Does it still that?
That mu sub d, difference in the population means.
That's it.
Sorry. If you want, you could write this. At the 0.05 level of significance. If you want to write that too. At the 0.05 level of significance. You don't have to. We already have it. Conclusion. There is not sufficient evidence that mu d is greater than at the 0.05 level of significance. Cool. Hey, I wanted to run through two more problems with you, okay? First of all, let me go back to the screen, and we'll do one like this. All right? A lot of you are like, well, this is a lot of fun. Except for one thing, it takes a little time. If you're in a testing format, I don't have to be brief about this because you'll understand this. If you're in a testing format, it could take a few minutes to enter all that data. Do you agree? So what you do is, let me read these two numbers right here off the screen. It's like, so for testing purposes, I could just get those two important numbers off the screen. So what was x bar the differences? X bar sub d was
5.1.
5.09, 5.1. What was s of the differences? I know the calculator says s of x, but what's s of d?
14.87.
14.875, 8758,
Okay.
876. Sound good? I'm gonna hit the lights. This is all I'd have to do. I mean, I could show you all this stuff, but boy, I'm gonna save 10 minutes for many students. You know, you talk about this problem here, but give the students these two numbers. All right? See, I know you can do all this stuff, but I'm talking in a testing format where you kind of rush for students have to do like a bunch of other math problems, like a final exam. Provide these for the students. You go, why? So you go, all right, here's all the stuff, here's all the differences, but this is the mean difference. This is the average of all these differences, and this is the standard deviation of all these what? Differences. So now, you go here, everyone go to t-test. Pretend those two numbers are given to you. Well, when you go to t-test, right? Stat, test, t-test, you go here and you go, all right, he gave me the stats. So I don't have to enter everything into what?
Data.
So I'm going to hit stats, keep this as 0, look on the paper, oh that's 5.09. Look on the paper, oh that's 14 point what? What was it? 876. Sample size, you do have to put the sample size though. What was it?
11.
11. Greater than. Calculate. 1.134. The reason that's a little bit different is because I rounded those, but still it's good enough for estimating. P-value 0.14. Isn't that cool?
Mm-hmm.
So it'll be, you can go quick on this. You follow me? And you're concentrating, I hope, really on that p-value, right? And you'll do the classical approach, but you'll focus on that p-value. Cool. Also, maybe to save time, it's like final exam, you might say, hey, listen, a box plot and the normal probability plot already indicated that the distribution is approximately normal with no outliers. So you don't have to go through all those motions. Sound good? Awesome. Hey, so let's do one like that. Let's do a problem where what? They just gave us the mean difference and the standard deviation difference. If you have your textbooks, great. If not, I'll read it to you. Everyone, this is on page 550. It's number 6. All right. I still think we have time to do a bunch more of these. What were the other observations I liked? They only had 8. I'm going to wipe this out. I'm going to go like this. I'm going to keep differences. Wipe all this stuff. Woo! Alpha level for number 6 is level of significance is 5%. And when this is about a caffeine enhanced workout. Okay, so let me read this to you. Someone is looking at whether or not caffeine helps you in your what? Maybe an athletic performance. Maybe you're about to go run a mile or something less, or run 100 miles or something, or exercise. They want to know if the caffeine enhances your performance. Okay. Many studies have been conducted to assess the effect of caffeine on athletes. And you can actually look at everyone in the Olympic rules about what's the limit amount of caffeine like the athlete can have before their what? Their performance of the race. I believe there is a standard, like you can't have this amount or this amount. Could be wrong, but that's alright. So researchers at the University of Western Australia conducted tests to determine the rate of energy expenditure, it's in kilojoules, on 10 healthy females. They were non-regular caffeine users. Each female was randomly assigned either a placebo or caffeine prior to the exercise, 60 minutes. The subject rode an exercise bike for 15 minutes, 65% of their maximum heart rate, and the energy expenditure was measured. Okay, so they measured the energy expenditure. The process was repeated on a separate day by the remaining treatment. So once again, everyone, when the person got their stuff, they took it, did they know whether or not they were getting the placebo or the caffeine?
No.
No. And they did it one day and then they did it the next day. So if someone was given the caffeine the first day, they got the placebo the next day, vice versa, right? Alright, and he looked at this, and we're trying to see if the caffeine enhances the what? The performance. So it's like this. We can look at this as, okay, this will be the caffeine, placebo, and what would be our difference? Caffeine minus what?
Placebo.
Minus placebo. Caffeine minus placebo. Okay? But, here you go. All they gave you in this problem was the mean difference. That was the mean of all these. Now, there were 10 of them. So I do want to point out this had a sample size equal to 10. So everyone, just a reminder, sample size was 10. I didn't want you to think it was just 8 of them. I'll just put a 9 and a 10 here. 10, 9, 10. All right. But in this problem, they just gave us the values. They said the mean difference in energy expenditure was 18 kilojoules. Standard deviation of the difference was 19 kilojoules. Alpha level 0.05. We're ready to roll. They already did this for us. Okay, thanks. Save us a little time. So another proper setup for exam, final exam. If I'm like, I don't want them to spend 10 minutes entering all the data. Someone got this? And it is difference, I'm talking about caffeine minus placebo. We're trying to see if the caffeine enhances the performance. So, hey, my setup of the hypothesis test. What's this? What's the null?
0.
0, matched pairs. Mean difference 0. Why is it matched pairs? Same person twice. Caffeine, placebo. All right. By the way, you can do stuff like husband and wife and twins and stuff. What's my alternative? What do y'all think? That the caffeine minus placebo will come out what?
Greater.
Greater. Yeah, it's helping their performance. So that's the alternative hypothesis. Verify requirements. We were told that this was approximately normal. They said assume the differences are normally distributed. So just put a check right there because right here they said in their writing, assume the difference data are normally distributed. No outliers. If they gave us data, we can look at the box plot though, right? Yeah, we can look at the box, make sure there's no outliers. Do I look at that data? No. Do I look at that data? No, I just look at the difference data. Make sure there's no outliers. We would do a normal probability plot on that if we had the software for that. Alright? Awesome, you ready to roll? Where are we going? Take us a second. Stat, t-test, right? Number 2. Let's roll with this. And after this one, I want to do one more where I'll grab some more data from the book. Just so I looked at something that's kind of interesting. All right, mean 0. What's the X bar?
18.
18. Standard deviation?
19.
So we always use t-test for matched pairs. Just the t-test, but sample size this time is
10.
10. 9 degrees of freedom. All right, and then we get the what? Greater than? All right, look at the p-value. That's what we all want. Ah.
0.004. Oh, no, but it's still higher.
Ah. P-value
Oh, no, 0.0007.
0.0007.
Sorry, no, 0.00. No, low.
That's low, super low.
So we reject the whole.
Reject the whole. There's evidence the caffeine's doing what? Enhancing performance. All right. Well, I'm gonna write this out real quick. Whoop, whoop, T, shade over here,
How much am I shading?
5%.
5%. Now when I'm gonna look up on the T table what my T crit is. Look, change my chalk, T crit.
I always get T crit, I'll use this. Unless you got inverse T.
They're like inverse T. 0.05, but this time how many degrees of freedom?
9.
9 degrees of freedom, right? Well, look here at 9, 0.05. You'll get 1.83?
Yep.
1.83. What's the T right there?
2.99.
2.995? It's in the critical region. The p-value? .007. Because my p-value
It's low.
is lower than the alpha, what are we doing about the hoe?
Rejected.
The null hypothesis. We reject the null hypothesis, right? And when here comes my conclusion. Conclusion?
There is evidence.
There is evidence. There is sufficient evidence. Suggesting what? You want to put it in words with the caffeine? You can. I'm just going to write u sub d greater than 0. But do you want to put that in words?
Caffeine
The
in
mean difference in energy expenditure is greater than 0, right? Mean difference in what? Between the caffeine and the placebo. Hey, super job. I wanted to do one more because I thought you all would like this. And when you ever go up to the Chesapeake Bay, look at the water, kind of dirty. You're like, maybe from afar it looks nice and blue. Get up close and you go, ugh.